In problem number 1, they're asking me to interpret a confidence interval. So in a confidence interval, I'm saying something from the sample about the population. So I need to have the word true, or I need to have the word actual in my interpretation. That means B is incorrect. It's missing the word true. C is incorrect, and so D is incorrect. So I need to look at A and D to figure out which is correct. And A is correct because we're doing a 95% confidence interval that it's within those values, plus or minus 3%. Question number 2 is asking me to interpret the confidence interval for a mean. I'm going to do it the same way as I did number 1, which was a proportion. So they want to know which of the following is the correct interpretation. So first thing I need to do is look for the word true. A and C are the only ones that have the word true in it. That means B is incorrect, D is incorrect, E is incorrect. So answer C is the correct answer because remember you were supposed to memorize that we are 90% confidence and then put the rest of it in context of the problem. In problem number 2, they're asking me if we understand the confidence interval, which is made up of the stats plus or minus the margin of error. The margin of error consists of my critical value and my standard deviation. So we're talking about means, so that's my standard deviation for a mean. They want to know which one would produce a wider confidence interval. So if I look at my levels, so I start at 95% right here, and if I increase it, notice my critical value is getting larger and larger, so that would make my critical value larger and larger. And then when I look through the rest of these, A is the only correct answer. Question number 4 is discussing problems with a recent poll. So my margin of error consists of my critical value and my standard deviation. So I'm going to take my point estimate. So I'm going to look at my choices. The first choice is a response bias. People didn't answer the question. The second choice is people weren't asked. That's under coverage. The third one, people won't answer the phone in several calls. That's response bias. So now they're asking which is included in the margin of error. These 3 are questions about how it's sampled. The margin of error is a critical value and the standard deviation, so none of those are correct. In problem number 5, they're asking a question about the standard error. Here is my formula for the standard error. In the problem, they tell us internet use is 0.7. So that is my p hat, and then I can do q hat also. So that's how I got the 0.7, and that's how I got 0.3. They say my standard error is that number, so that goes here. To solve this algebraically, to make it really easy, all I'm going to do is take this number and switch it with this number. So now I need to solve the equation. So I'm going to take this, get the square root, divided by the standard error. That equals the square root of m. So I'm going to take that and square it, and that is 100. In problem number 6, they tell us there are 16 students, test scores. They give us the mean, 200. They tell us the standard deviation of the sample. So we don't know sigma. That's why we want to know the standard error. So my standard error Because I don't know sigma, I'm going to use S instead. So I go ahead and calculate that, and I get 5. Make sure you see the formula sheet. This is on the formula sheet. In problem number 7, they conduct a survey. The newspaper took a simple random sample of 1,200 voters, and they found 620 voted for the Republican candidate. So this is a proportion because they either voted for the Republican or they voted for somebody else. So we're going to let rho be the proportion. So all proportions, I am going to use z-scores. So I want to construct a 90% confidence interval. So my p-hat is 620 over 1,200. So that's how I got 0.517. I am looking for a 90% confidence interval. I'm going to look on the t-table at the very bottom, look for 90% for my critical value, 1.645. Here's my equation. Here's my point estimate. Here's my critical value. I am going to use p-hat, 1 minus p-hat divided by 1,200. So this is the equation I get. Notice they wrote it so I can't do it on my calculator. I have to know how to do the formula. In problem number 8, about a football team, and either they win, either people are in favor of firing the coach or they're not in favor. So this is a proportion. So they want to know what's the smallest sample size that I needed. So I am looking for my margin of error within 0.05. So my margin of error is my critical value, and because it's a proportion, I look up my z-score. So the critical value at 95% is 1.96. I don't know my standard deviation, so I'm going to use it, make it as large as possible. So I am going to use 0.5 and 0.1 minus 0.5. That's how I got square root of 0.25. To make this easy, if I have 0.05%, I'm going to take this and switch it with the square root of n. So now I got 19.6 is less than or equal to square root of n, square both sides. So I have to round this to the nearest whole number. That would be 385. In question number 9, I have to first figure out, is this about proportions or is this about means? So the employees had a service time of 7 years. That would be a mean. My standard deviation is 2 years. Standard deviation of the sample. I don't know the population, so I have to use a t-distribution to make the 95% confidence level. I have 100 postal workers. So if I have 100 postal workers, my degree of freedom is 99. So here's my formula. I'm going to take my stats, my critical value of t, times the standard deviation. So I'm going to look up t. I am looking for 99 degrees of freedom. I don't have 99 on my table, so I have to use 8. So I am going to use 1.99. If you do in the calculator, you're going to get the exact value, but 1.99 will work. So I'm going to take my point estimate and multiply it by plus or minus my critical value of t times 2 over the square root of 100. So that's how I got D. In problem number 10, we have 4 students. The students take the SAT test 2 times. Their first score and then their second score. This is one sample. because I'm doing testing and retesting. I want to find a 90% confidence interval. So now I have the data. So I need to use my graphing calculator to find my point estimate. So I'm going to put everything in list 1. I put my first scores in one list, my second score, find the difference, and then I'm going to find the mean difference. So the mean difference was 25. I do not have the whole population, I only have a sample. So I get my standard deviation of the sample is 40.4145. The number of students I have is 4. So this is about a mean. I want to find mean. It's not about a proportion. So I don't know the population sigma. That means I have to find a critical t, not a z. So my degrees of freedom is 3 because there's 4 people. 4 minus 1 is 3. I am going to look up on my table. My critical value for a 90% confidence interval is 2.353. Here is my formula. I am going to plug my values in. There's my point estimate. There's my critical value. Here's my standard deviation of those 4. This is how I got C. In question number 3, we're asked to construct a confidence interval. So we're going to use the panic method so we don't miss anything here. So P is my parameter. So my parameter, I want to construct a 95% confidence of the true. And then make sure you put it in context. My assumptions, A, is going to be random. So the problem states it's random. Normal, there are 35 samples here. So the central limit theorem says it will be approximately normal. And then I'm going to name my interval. Since we don't know what sigma is, and we have to estimate it using the standard deviation of sample, we are going to do a 1 sample t confidence interval. I am going to do my calculations. Here's my original formula. I'm plugging my numbers in. Here's my confidence interval. I need to interpret it in context of the problem. So we are 95% confidence, give the interval. Make sure you say the true or the actual amount. So here's my interval. They claim that 12 ounce, the cans are filled up 12 ounces, but that's not on the interval. So it appears the machine is underfilling the cans of pop. And question C, make sure you know the difference between a level and an interval. So a 95% interval, if I took many samples, about 95% of them would capture the true mean.